Howdy folks, unboxing and review day today. Before getting to it, just a little bit of background though. Anyone who follows my channel knows I purchased one of these TS100 soldering irons several weeks back. And as I mentioned on that, just how great these are. And the primary reason is because they use the cartridge style or direct drive tip technology, where the sensor and the heating element is built right into the soldering tip, giving incredibly quick response times and very accurate heat control. And once I started using this, the problem I found is I was liking it so much. I found it so much better than my old soldering station that uses, well, it's not even that old, but it uses the old technology, you know, the tip that slides over the ceramic element, and it had me longing for a soldering station with this same technology. And, you know, I looked at the Hakko FX951, beautiful station, but here in Canada, $350 over and above what, you know, myself as an RC hobbyist and part-time electronics hobbyists could justify. So my search was on for a good alternative to that. Now, there are Hakko FX951 clones out there. They look the same and everything as the Hakko. But I saw a review from Dave Jones and a few others. I wouldn't spend, you know, 120 or 150 bucks on one. Then I started finding these things. And these are what are known as T12 soldering stations. So they use the exact same tips, the T12 or the T15 cartridge style tips that the Hakko uses, but get this, price 50 bucks US, around 70 Canadian. And I looked for a long time, and there's a lot of versions of these out there. This one is made by a company, KSGER, or if you want to call them KSGER, and this one kept coming up as, you know, the one that had the best features for the dollar. I'm going to open it up and we're going to go over that. Before going any further, I want to thank Banggood for sending this to me to review. I was going to buy one of these regardless, but timing was just perfect and they agreed to send me one. So thanks to them. And I'll have links to this and the other stuff I've got here down below in the description, so you can take a look at them yourself. So as you can see, it's quite small. Comes with 4 little rubber feet on it. It's got a 5-pin DIN connector for the soldering iron itself. Little OLED display. Take this off right now. As far as menu selection and temperature selection, all done through this push button dial. This is indexed, and I much prefer a dial on a soldering station for temperature selection over push buttons, but that's just preference. On the back, these don't come with a power cord, so you're going to have to supply your own power cord. Just uses a regular, you know, a computer. What are these, C13 plugs? They plug into a C14. That's what that is. So most of us have got these lying around. If you're, you know, RC power supplies, most of them come with them. Of course, computers, monitors, that type of thing. If you don't have one though, you can pick them up cheap enough. On and off switch, and it's even got, it's fuse protected. There's a little fuse in the back, which is nice. So that's the station. We'll open up. We'll look at inside of it as well. It comes with a knife, a T12K knife tip. Best for, you know, electronics hobbyists, for reflow work on boards. So I'm not a big fan of these tips. So for RC use, I wouldn't. I would get more tips, and I actually did get a tip set for this as well. It's a 9-tip set. I'll link to that as well below in the description. And it's got a whole bunch of useful ones that most of us will use. And that's the other neat thing with these T12 soldering stations. You can get a whole set of these tips for around 20 bucks, whereas a single tip for the TS100s are, you know, anywhere between 12 and 15. So tip price is much cheaper. Now, I've heard that these may not last, or probably won't last as long is an actual genuine Hakko T12 or T15 tip. But again, for, you know, hobbyist use, I suspect these are going to be fine. And these are exactly the same as the Hakko tips. And speaking of that, let's look at the iron. And that was another feature that, a selling feature, was just how nice this iron is. Soft silicone wiring, very flexible, and oops, we'll take it apart, but soft, nice soft grip, silicone as well, and the tips just slide in, click in really nice. And what's so nice about this is your working distance. You know, you're right there, so you've got great control. You know, here's my previous soldering iron. Oops, sorry about that. And you can tell, you know, where I'm holding this, you know, and this has got the fume extractor. That's the one thing I'm going to miss. Might have to buy a separate little fume extractor fan now, but because I did like the fume extractor on this thing, but just not nearly as nice to hold. You know, you've got all this wiring. It works, but this is just so much nicer. The other thing that I picked up here, which I would suggest getting if you get one of these, and they're not that expensive either, is a soldering iron stand. And I will link to this as well. But again, it's kind of a Hakko, not quite a clone. You know, it's a nice stand like this is nice. This is made from heavy cast aluminum. Might want to put some rubber feeder or something on it so it doesn't slide around. But it will hold the iron very nicely, perfectly in fact. Just sits right in there. And it doesn't come with a spongy, so you're probably going to have to pick up a spongy. This one doesn't fit, you know, your brass shavings or sponge, or you could put just a regular cellulose wet sponge in there, up to you. This is the 9501 iron, which was a big selling point. Very nice, and it is electrostatic discharge safe, so this should be grounded. I'll go to our ground pin here, and there we've got so the tip is grounded. Let's get into this thing. Thought we'd start with the soldering iron itself. So to get into these, we can just unscrew the end, and that's what holds the tip. Holds it pretty stiff in that, and then of course the contacts are inside the iron itself, the iron body itself. Very lightweight, again very nice cord. Just take the strain relief off, which this appears to be silicone as well. And then I imagine this just pushes out. Yep. And there's a guide slot in there. So looks like there's a little marking here so you know where to line it up. And there's our guts of the iron. This is just a 3-point contact for the tips. So you've got your two driving, this is for the heater and the sensor, and then this is for the ground, to ground it out. Black and red feed the power. You've got the green for the ground, and then there's a blue in here as well for the motion sensor. This is just a little motion switch. I doubt it's a mercury switch. It's probably just a little ball one. You can actually hear it shaking a little bit. And I bet you if we've got this on continuity, we can see how this works. Yeah, so the idea is if you're not using the iron and the station doesn't detect any movement for a programmable set of time, first go into sleep mode and then it'll turn right off. So great safety feature. One little disappointment I found, this is the end of the soldering iron, this is the DIN end. Not overly impressed with these soldering connections on here. I'm going to redo them and put heat shrink over them. There we go. a little happier with that. Back at the soldering iron end, my OCD got the better of me, so I redid all these solder joints too. There was nothing grossly wrong with them, but not something I was overly happy with after doing the other end. I wanted to do this as well. This is a 5-wire silicone cable, which you can buy these online as well, so if you ever have to change out the cable, these are easy to find. Anyways, your 5 wires, as we had mentioned, we've got the red going to one of the power contacts, the black going to the other, so those are your main power feeds. They also backfeed for the temperature sensor. This is the ground. There's our mechanical motion switch there, which goes to the blue wire, and I've heat shrunk that. And then the white wire goes up to this, it looks like a little Zener diode, but it's one of those axial NTC thermal thermistors, also known as a glass thermistor. And this is what measures the temperature in the iron handle, I should say, not the iron tip, don't get that confused. So this, you can have the station read the temperature in your handle, or you can read the CPU temperature off of the microchip. You've got those two options in the setup. But anyways, just thought I'd go over that real quick. You can see there's these little notches for tie straps. I would have liked to make this perhaps a little bit shorter. I might put heat shrink over all this now, but I think this looks a lot better than how it came out of the factory. Yeah, it might just be a one-of. I got somebody who didn't really know what they were doing. They were training, whatever. I would suggest at least opening yours up if you get one, and just double check that. And if you don't like the solder job, redo it yourself. You know, that's part of the fun with this kind of stuff. Into the belly of the beast. There's not really too much to these. The majority of these T12 soldering stations, at least this one, this particular one, as I said, there's different versions. And the reason I like this one so much is because of the power supply it comes with. But before getting to that, this is what they all have in common. This is the control interface and the brain box. Like our little TS100 soldering iron, this thing is also controlled with a 32-bit ARM microcontroller, the STM32 to be exact. That's it right there. And you know, it's got a little buzzer on it. Here's your main voltage input. The power supply is rated at 25 volts. And then this little plug goes to this thing here, which is the backup battery. This thing's got a clock in it, so it uses a little backup battery. It's got the little OLED display on it, and your 5-pin DIN input, which is direct hard soldered to the board, and then your dial interface. And this is, you can get these in kits too. You can find them as kits. And another neat thing is if anything craps out in here, you can go and find the replacement parts. So if your if you know the brains of it crapped out, you can go out and buy a new one. Now, the power supply, that's why I was so impressed with this particular board. Very well done. Nice big heat sinking. Here's our input side of it. So we've got a choke, a capacitor, the normal type of stuff, rectifier, MOV, big power cap to smooth the voltage. And there's also another through-hole board fuse, so it's double fuse protected. Not only do you have the one here, you've got another one here. And then this is our, I believe this is the rectifier. This is a 2200 CTG diode rectifier, big heat sink, and then this here is a 20N60 MOSFET, so it's a switch mode power supply. That's what's doing our switching. And the other really cool thing, hopefully you can see this, sorry I was out of frame, you've got this massive isolation slot. It starts here, goes down, goes through the middle of the transformer, over here, and then you've got an optocoupler on this side. So everything from the primary side of the board is completely isolated from the secondary output side. If you're working on sensitive electronics, it's really nice seeing that level of protection. Really good protection. So that's the main reason I like this one so much. Again, you can get these in kits. There's other versions of it, but this one has got the really nice power supply. It's on. A little red LED indicator comes on. So let's see what this thing is outputting. Make sure my big paw doesn't get in the way here. It's not only does it have the output on this plug, there's two more pads right on the board. And what are we sitting at? 25 volts roughly, 25.5 volts. I'm guessing power is probably about, probably 5 amps, might be a little bit more. That's just a guess though, just knowing how much these irons draw. They don't draw all that much. Now, I'm going to get it all back together. I'm going to have to play for a while. No instructions whatsoever, folks. We'll now go through power up sequence to show you what's going on. We'll go through all the menu settings. So when you power it up, it doesn't show anything right away. It's booting up. It takes a few seconds to boot up. And I've got mine set so it boots up in standby mode. But let's just take it out of that. So you can see how quickly it's coming up to temperature. There we go. So this is what temperature we've got it set at, 300, and this is the actual temperature of the tip. This is your input voltage. This number here is the amount of power being sent to the tip. So 20% power roughly. You'll see if I quench the tip in a wet sponge, here's our tip nicely up to temperature. If I quench it, you'll see that power jumping up all the way to 100% a few times. But you can see, look at the tip temperature here, the big number. How quickly it reacts and how closely it's staying to that set 300 degrees Celsius temperature. And I should mention, this only reads in metric and Celsius. There's no function to switch it to Fahrenheit. If you don't like Celsius one bit, probably pass on one of these. This is our real-time clock. This is one of the fails on my unit. I'm not saying everyone. We'll go over that shortly. And then this is the temperature. You can set this for either monitoring the temperature of the microcontroller. All these little STM microcontrollers have a temperature sensor built in. Or you can check the temperature of the that NTC thermistor up in the handle of your soldering iron. Not the tip, but what's up in the handle. To adjust the temperature, you just push this in and you dial it up or down. So let's dial it up to 50. You'll see how quickly it responds. Boom, it's there. That's what's so awesome about this direct drive tip technology. Now we'll go back down to 300. If you hold it in and turn it, this is where you select what tip you've got in it. And you might wonder, well, why do you have to do that? I've actually got a K tip in it too. These things work on PID feedback algorithm loops. Same idea as what's in your stabilization flight controller on your helicopter's flybarless unit or your quadcopter's flight controller. These use PID control algorithms, and that's why they react so quickly and why they're so accurate. And depending on what tip type you've got, will change the actual PID algorithm. They're pre-built in, you have no adjustment over that, but it makes total sense. You know, different tips, they'll have different thermal mass, different shapes, they'll bleed heat off quicker or slower. So the PID algorithm will be matched to that tip. Hold this in and turn it to the left. What happens there? Oh, and there you can adjust the tip temperature. So if you press the button in and turn it to the left, you can actually fine-tune the tip temperature. So if you've got a temperature probe for your multimeter or something similar there where you can measure the tip temperature accurately, you could really fine-tune your tip adjustment. I checked the one tip and it was within 10 degrees of what was indicated on here. So I think these are pretty accurate, but if you wanted to adjust it, that's how you do that. Now, to get into the main menu, you hold the button in for several seconds and it will go into your setup menu. And here you've got 21 different options or fields. So Let's just take these one at a time. So let's do one. So this is standby. This is after you stop using the iron, you put it away in the holder. You know, you're still working on the bench. How long it takes before it goes into standby mode, meaning it will ramp the temperature down. It won't turn the iron off, it'll just ramp it down. It allows you to select what that temperature is, how long it will stay in the iron before it does go into standby mode. I've got it set to 5 minutes. And then how you want it to wake up. So I've got it to shake. So as soon as I pick up the iron, it will, you know, in that little motion, that mechanical motion switch in there detects movement, it will wake it up from standby mode. It'll take it out of standby mode. And now to get out of this, you just hold the button in again. We'll go to sleep. Now this is how long it takes to go into sleep mode, which basically turns the iron off. And in sleep mode, you cannot wake it up by moving the iron or anything. You actually have to manually press the button to get it to wake up. And I've got mine set right now to 15 minutes. And you can dial it anywhere from 1 minute up to 60, I believe. And that was the same with the that was the same with the standby. Okay, we'll go to boost. This is a function if you want to momentarily boost the temperature of the iron. Maybe you do a lot of similar work and you're doing lots of PCB work, but every now and then you've got a big ground plane to solder up or some big wiring. You could set this boost temperature, you hit the button, and it will boost it up to whatever temperature you've got set. And you can boost it all the way up 100 degrees. So if you've got your iron set normally at 300, when you engage the boost, it'll go up to 400. And then I'm just going to put it back to what I've got it set at 40. And then the duration of how long you want it to boost. You've got anywhere from 1 minute up to, looks like 30 minutes. Cold end. This one took a while to figure out. As I said, there's two sensors you can have this read from. You can either read it from the little microcontroller sensor, they call it the CPU, or you can read it from the NTC thermistor up in the handle of the iron. That was that little glass or axial thermistor up there that I was showing you. And then so you can select either of those. I'm going to monitor the CPU temperature. I don't really know why you'd want to monitor the iron temperature, and that's that little temperature display that was in the bottom corner here. That's what this is registering, either the CPU or the iron handle. And this is an adjustment. Now this took a while to figure out, but basically whatever you adjust this at, if I turn this down to 0 now, and we got out of the menu, it would show 0 in the display for the temperature. So think of it as a calibration. What was that at? I think 24. I'll have to do it. So basically what I did is I just, I knew what the room temperature is when I first turned it on. If it's 21 in the room Celsius, then I set both of these at 21, and then it counts either up or down as the temperature changes. So just think of that as a calibration number to set it to whatever your room temperature is, and then it will either go up or go down as it heats and cools. So it's kind of a weird setting, but I think that's how it works. I played with this one for quite a while to figure it out. Tip, this just goes through a whole list of all the different tips that you can program into. This basically, when you have a check mark or take it off, that just puts the tip into your inventory. So you don't have to scroll through a whole bunch when you're setting what tip you're using when you first turn it on or if you change a tip. And there's up to 99 options here. So they've got every tip under the sun, and they even have user-defined tips. Way more options than I'll ever need. Stepping, this just dictates how many degree increments the temperatures will go up or down when you dial this. If you noticed, mine went in 10 degree increments, so when we were dialing it up to 350, it went to 310, 20, 30, 40, 50. You can set that down to 1 degree increments all the way up to 50 degree increments. And that's per click. Remember, this is an index dial, So every little click will increase it 10 degrees. Password. This is if you wanted to lock out any programming. And yeah, if you've got different people using the station, it might be something useful. You know, I've got it turned off right now, but you can turn it on, and then after this is selectable, after whatever time you set in here, after 10 minutes, no one would be able to go into the programming to change anything. And then it gives you a password. I just set it to 1234, but I, of course, am not using this. I don't think most people will, but the option is there. Screen save is just on or off. All it does is it moves whatever's displayed on the screen around, so all the same pixels aren't constantly lit up. And how long it takes for it to go into screensaver mode. I've just got it set at 15 minutes, and here you've got anywhere from 1 minute to 60 minutes. Buzzer, very simple, either on or off. It'll beep when it does certain things. It'll beep actually if you're soldering and you put the iron away and it's not being used and it's about to go into standby mode, it'll start beeping. So if you don't want it to go into standby mode, just pick the iron up, shake it, whatever, or push the button, and it'll take it out. It'll restart the counter for standby. Same thing for sleep. So I like having that turned on. Voltage just displays the voltage or not in the bottom corner. If you turn that voltage off, instead of the voltage showing here from the input voltage, it will show the tip type that you've got selected. So if we change the tip type, let's change it to a BC1, then it will show your BC1 that is selected. That's what I'm going to be using. I don't really care what the voltage output is from the power supply. I'd be more concerned with what tip selection I've got. Low power, this probably more if you're running this off of a battery. The T12 circuit in here, you can get them for any kind of project, right? So you could power this off of a battery if you wanted to. Of course, we're powering it off of the switch mode power supply, so we don't have to worry about that. That's why I've got it turned off. Power on, just when you turn it on, what mode it goes into. As you know, mine went into standby mode, but you can have it go right to running, or you can have it go into sleep mode when you first turn it on. Now, these next two, desolder and pump set, no idea. Must be options for this panel that are not supported by the included hardware. No idea. If anyone wants to comment on what those two are, please do so down in the comments. Language, this one had me going for a while. Out of the box, it came in Chinese. Yeah, I didn't know which one to select. So if yours comes with the Chinese default language in there, you have to go down to number 15. That's the one where you set your language. Date and time. This is where you would set your date and time, which I did, but I've got a problem with my backup battery. It's completely stone cold dead, and it won't save the time. If I set the time and I turn this off, I lose it all, and it goes back to January 1st of 2013 at 0 hours. So that's one of the fails on this. I'm not saying they're all like that, and I'm going to talk about that battery a little bit more. I don't really see a reason to have date and time, but if you want that, you're going to have to make sure the backup battery is okay. Real-time clock adjust. Seeing that my clock is useless in this case, I don't really need this, but if it's running fast or slow, you can dial it up or down to increase its accuracy. And real-time clock initialize just resets it. System info tells what hardware version it is. It's 2.1S, and what software version, 2.10. No way to update software, no USB port or anything in here, so you get what you get. There might be some hacking mods out there, I have no idea. Not at all interested in that kind of stuff. 20 initializes it back to factory settings, don't want to do that, and 21 exits. A few things to point out on the power supply again. First thing, I made a mistake. I called this a MOV. I didn't look close enough. This is actually an NTC thermistor, a 5D9. You see these on a lot of power supplies. It's I believe it limits the current depending on the temperature. Don't quote me on that. I think that's what their purpose is. You do have a MOV though on the back side. The other neat thing with this, I was saying about the protection, but the other cool thing is all the components, you know, they're all off-the-shelf components. So if anything fails on this board, it'd be really easy to repair. You know, for the average electronic hobbyist, there's not too much SMD stuff. Most of it's pretty big. You know, that's up to you. You can buy new boards for pretty cheap, new power supply boards. Although it's hard to find these nice ones with the big isolation slot that are optically, you know, isolated and everything. That's what was the big plus with this. Anyways, this silly battery here that I had mentioned, I've seen other ones of these and the battery's mounted on this, on the control board. But this one, they've put it on top of the transformer. And in that location, I couldn't figure out why this didn't quite fit right. And it's because the battery is sitting too high and you have to really force this down to align the screw holes up in the four corners. So you're putting a bunch of pressure down and you're flexing the board. Not a good thing. So if you've got one of these are held on with a little bit of sticky tape, like double-sided tape, so it's sat even a little bit higher. But you know, I was just going to move mine somewhere else, you know, off to the side down here somewhere. But as it is, it's stone cold dead. I unplugged it. I checked it with the voltmeter. 0 volts out of this thing. I don't know. It's probably, I don't know if it's a 2032, but my guess is it's just a 3-volt button cell. So if you want clock memory and you get one with a dead battery, you're probably going to have to replace it. Or just yank it out, which is what I'm going to do right now. Don't need it. All the other settings are memorized. That's just for the clock. If you don't have a tip in or your iron isn't plugged in, you get a big error reading, which makes sense. Now, the one other thing that is a bit of a quirk, at least on mine, when I first put in new tips, and I've put in most of them now, here's a new one I've never plugged in, it's almost like it has to heat the tip up to operating temperature and go through some process in order for it to start working properly. When I first plug it in, it has this intermittent error that keeps coming on and off, and the tip doesn't come up to temperature right away. It takes a while, but after it does it the first time, then they all work fine after they've been initialized. But it's kind of weird. So we'll do this. I'll show you what this is. So this tip has never been used before. I'll plug it in. See, it overshoots quite a bit, then it does this error, and it's almost like it's hunting and learning the tip. And this has done this for every brand new tip, but only when it's brand new. Once it's gone through its, I'll call it an initialization phase, and then it's fine, and it works perfect after that. If anyone's got any comments on why that is doing that with just brand new tips, I'm sure everyone would be interested. Time to wrap this KSGER T12 soldering station review up. I'll go over the pros and cons and my final thoughts. We'll start with the cons. Biggest one for me was the backup battery for the clock. I guess if that's my biggest one, we're doing pretty good. Its mounting location was unacceptable, flexing the board like that. And of course mine came stone cold dead, so I have no battery backup for my time or date. Not a big issue though, and easy to replace. Next one is the soldering quality in the DIN connector, and to a lesser extent up in the wand. Of course that's anecdotal to my particular unit, but if you do end up getting one of these, might not hurt to check. Easy to take both ends off to look at the wiring, and if you don't feel the soldering quality is up to your standards, you can easily tag them. The tip that it ships with, the K tip, the knife tip, of little value to my application. Of course, that's application dependent. If you're doing reflow work on boards, these are a great tip. So again, not too much use for me, but that would be the only last little con. Of course, tips are easy and inexpensive to get. The T12s or the T15s. This 10 set was 22 bucks, and it has everything and more that I would use. The only one I don't see in here that I would like is a D24, a 2.4 millimeter wide chisel.
You can pick those up separate, and of course these are the same style, size, dimensions, everything as the actual Hakko T12 and T15 tips. So you can also use Hakko tips. As we saw in there, there's many tip options. Nice OLED display, bright enough for me. It's a little on the small side if you're viewing from a distance, but consider the small form factor. You know, it has to be considered, to me, a positive. Very nicely done, extruded aluminum, tough, high quality shell, nice high flex silicone wiring, silicone grip, very well balanced soldering iron, nice short distance, really easy to work on stuff, nice to use. The other nice thing is just how serviceable this is. You know, we saw when we were looking at the board, all the components are very serviceable, but even if you don't, you know, if you never want to get into that, if anything craps out, you can just buy the components for it. You know, buy a new board, buy the new main face board, the control board, new iron. You know, you can even just get the wiring. So in that respect, great for a hobbyist. Even the knob, you know, just a 1/4 inch standard splined shaft, dial shaft. So if you didn't like this knob that it ships with, it's a thin-walled aluminum with a plastic insert. If you didn't like it, you can get something else. Nothing wrong with this one though. Of course, powerful, 70 watts, direct drive tip technology, soldered 8-gauge wire, no problem, probably go up to 6. Of course, with the fine temperature control and how accurate it is and responsive it is, you know, you can do the most delicate of SMD right up to big wiring. So again, very versatile in that respect. And the price, you know, 50 bucks for the station, even with all the tips and the stand, under $100, and you're going to be hard pressed to find anything that costs that little that does so much and is so powerful with the technology, the tip technology this has. You know, is this a Hakko FX951 in terms of quality? No. At 1/6 the price, we can't really expect that. But consider what it does compete against. I'm thinking specifically of the Weller WL100, you know, that little orange soldering station that so many hobby shops sell. You know, a little 40-watt iron with, you know, analog wattage dial, no temperature control, very low power. Those are 50 bucks. This is an order of magnitude better than those. So yeah, if you're a RC hobbyist, electronics hobbyist, student, you don't want to spend, you know, $250, $300 on a Hakko. This will give you the same performance and technology pretty much. Quality is down, but at 1/6 the cost. So those are my thoughts on it. Hopefully if you're considering one of these, it might help out. I'll link to this exact unit with the good switch mode power supply in it below in the description, along with some of these other goodies. Take care folks, happy soldering.